Hey guys, welcome to 9.02. This one's about completing the square, a little bit more about quadratics. This one's kind of a fun one. It can be kind of challenging. A lot of people don't really like it at first, but I kind of in a weird dorky way sort of enjoy it, I guess. But I mean, you'll see. I guess you can make your own determination. This first page doesn't really give us a whole lot of information. What's basically saying is that quadratics can be written several different ways. You can have the standard form of a quadratic, like you see here, it's negative 2x squared plus 8x minus 6. You could also have the quadratic in factored form, negative 2 and then parentheses x minus 1, x minus 3. All that same quadratic but factored. Or you can even put it into what's called vertex form, which is totally new to us. We have not seen vertex form before. So there's a lot of different ways that the same equation, the same quadratic, the same parabola could be written, right? Different styles of writing it, the standard form, factored form, or vertex form. So obviously the main thing we're going to look at today is vertex form. Now, before we get too involved with it, let me go kind of explain quickly what vertex form is. Okay. And in a nutshell, it's pretty simple. Just go away thingy. Okay. It looks like this. You're going to have x minus h in parentheses squared plus k. Now, h and k are new to us. They're new letters. But h and k together make up the vertex. So if you have vertex form written, you don't have to do any math at all to find the vertex, like we did on previous problems where we had to find the x as a symmetry, plug that value in, and then get the vertex. If it's already in vertex form, then I can see with my own two eyes the vertex inside the equation. There is no math at all to work out. So what's an example of vertex form? Let's get some numbers here. Well, and I should put y equals in front of this, although really we're focusing on this part here. So an example would be like y equals x minus 2 squared plus 7. Now, in this case, the vertex of this equation would be 2, 7. Now, here's something that's very important to point out. The minus sign inside the parentheses. A minus sign indicates that the 2 is actually a positive 2, okay? So that can get people mixed up a lot of times because the h value is indeed the x value of the vertex, and the k value is the y value of the vertex. So we're using h and k rather than x and y, but they still are. The h is still the x value of the vertex, the k is the y. But the h is opposite from how it looks. So when you see x minus 2, the minus 2 is really the x value being a positive 2 in the vertex. And the plus 7, though, is pretty straightforward. The plus 7 is the y value, and it is a positive still as it is shown in the equation. Let's get another one, right? Let's say I've got y equals x plus 3 squared minus 2. All right. Now our h value is now plus 3. But in all reality, our vertex, that means the x value of our vertex is really a negative 3. And the k value here is the minus 2. That k value represents the y value of negative 2. So remember, it's the h value, the one that's inside the parentheses with the x, that's opposite from how it looks. So if you see a minus sign, it really means that number is positive. But if you see a plus sign, that really means the number is negative. And here's the reason why it's a negative. Because if you think about the original formula, if I plug in the h value of negative 3 into this formula or this equation, then I've got the negative from the formula joining forces with the negative from the 3, which the double negative turns into the plus sign, which is why you'll see a plus sign here, but it doesn't really mean it's positive. It really means it's disguising that negative, okay? So just be very mindful of that. Be very careful about that. But that's vertex form, and that's how easy it is to find the vertex in the equation. So if I give you one more, if I say y equals 2, let's say x minus 29 squared plus 10. Okay, the 2 is not really relevant as far as the vertex goes. The vertex is still the h and the k value that's in that equation. So of course, this would be a vertex of a positive 29 and then 10. So the vertex would be 29, 10, the point 29, 10. This comes from the inside part of the parentheses with the x, and this is the part on the outside, okay? The h and the k value, okay? So there's vertex form. The number in front is still, it's technically the a value, but we're not going to worry about that too much right now. So how does this work? Well, it works like transformations did. We saw that very briefly in the last section. So I've got my Desmos calculator here to show you. Now, the first one you see on this graph, you see x squared. Every quadratic is based, obviously, on x squared. So you see on the left bar, I put minus h and minus h and plus k. If I just put those both as 0, it's essentially just going to be the same as x squared. So you can see the red line is overlapping the blue line. It's pretty much the same thing. Because the vertex is 0, 0, it's still the same thing as x squared. But let's say I type in minus 1. You can see that the equation, the graph is moved to the right 1. I should really, there you go. Right, you can see the graph has moved to the right 1. Because remember, a minus 1 moves right 1, whereas if it was plus 1, it would move to the left 1. Okay, so something to keep in mind. And then the k value is its transformation upwards or downwards. So if it's plus 5, the graph is going to move up 5. If it's minus 5, it would move down 5. So the vertex still kind of tells us exactly how the function's transformed. So if I go back to this, right, right here with that plus 3, that would mean that the function moved left 3, and the minus 2 would mean that it moved down 2, because you still talk about those transformations. So if I actually put this one in, plus 3 and minus 2, you'll see it moved left 3 and down 2. So let me go to my calculator, right? Let's do that. Let's type in, oops, I got rid of the parentheses. I didn't mean to get rid of the parentheses. I'm going to have to type this whole thing out again. Okay, x plus 3, and then square it. Right? So you can see it's when you do the plus 3, it's moving to the left 3. That red line's moving to the left 3. And then when I put minus 2 at the end, it's going to move down 2. So it's left 3 and down 2. But it's also at the vertex. You can see its vertex is at the point negative 3, negative 2. As we said earlier, right? Negative 3, negative 2 is where that vertex is. So that's vertex form. It's very convenient. It's very useful, obviously. But yeah, and if you put an a value in the front of it, it's going to make it either narrower or wider. So numbers bigger than 1 are going to make the equation, the graph, more narrow. So if I put 2 there, the line gets skinnier. If I put 5 there, it's going to get even skinnier, right? If I put 15 there, it's going to be even skinnier. But if I put numbers, not negative numbers, because the negative number is just going to flip it upside down. So negative 1 would just flip it upside down. Negative 2 flips it upside down, makes it a little skinnier. Negative 5 makes it a little skinnier, right? It's still the same thing, still gets skinnier. Negative just flips it upside down. If I put a decimal number, like 0.5 in front, it actually gets wider. 0.1, even wider. 0.01, even wider, right? So that's how all those things can change. If you want to use a Desmos calculator, of course, just Google it, use it, and you can have some fun playing around with how things work. Obviously, you got the slider tool as well to show you. So the k value is going to move it up or down. And the h value is going to move it left or right. So if you wanted to have the k value move it down 2, like the equation I gave you, and if the h value is plus 3, this actually is backwards because it should be, if it's a positive 3. Well, I see what it's saying, actually. It's not considering the equation. But yeah. Okay. I see how that works. But there's the slider tool if you want to play around with that. But, Desmos works just as well. So when you look at these equations here, let me snip it. And you want to identify the vertex of these equations, it's really, really easy because there's no math involved. The h value is going to be the number inside the parentheses. So that minus 2 means the h value is a positive 2. And the k value is a number at the end. It's positive 17, which means it's positive 17. So the vertex is 2, 17. It's simply just literally looking at the equation and seeing the numbers. Now on the second one, the h value is plus 3, but it's actually, remember, opposite from how it looks. So the x is going to be a negative 3. But the y value is the way it's supposed to look like, the k value there. Y value, k value, they're the same thing. So the minus 4 is the y value being negative 4. So that vertex would be negative 3, negative 4. And then the last one, again, its h value is a negative 2, which means it's going to turn to really be a positive 2, and the y value being a positive 5. So that one would have 2, 5. And we could check that real quick. Negative 3, negative 4, 2, 5. Let's go. There you go, negative 3, negative 4 is the answer. 2, 5 is the answer. So it's very, very easy. You don't have to do any work. Okay, but now we're getting to the part that's the fun stuff, the completing the square. So we talked about a perfect square trinomial in the past. If you look at the example, x squared plus 6x plus 9 can be written as x plus 3 squared. Because when you factor it, it's x plus 3 times x plus 3, which of course means the same thing as x plus 3 squared. So that's going to be something that, that section comes very useful here, because we're going to need that. When we're talking about completing the square, we are talking about these perfect square trinomials. So let me give you some practice as to what's going to happen, right? So let's say I have a quadratic, and I want it to be a perfect square quadratic, okay? Perfect square quadratic. Let's say I have x squared plus, well, let's not use the one that they use. Let's say I have x squared plus 10x, right? My question is, what should this c value here be? If it's a perfect square trinomial, what number should c be? And so how we would find that number is we would take half of this number. So we would take 10, we divide it by 2, right? And then we would square that number. So there's kind of a really basic formula. It's the b value divided by 2 squared. And so what do we get when I apply that to this one? 10 divided by 2 would be 5, and then 5 squared would be 25. So 25 would be the number that would have to go here for it to be a perfect square trinomial. Let's do another real quick. So if I have x squared plus 14x, what number would have to go here? Remember, try to use the same formula, right? Take the b value divided by 2 and square it. So in this case, 14 divided by 2 and square it. 14 divided by 2 would be 7, and then 7 squared would be 49. Okay? You kind of get the idea? That's what's going to be as part of completing the square. Let's do one more. So let's say I have x squared plus 22. Let's use a minus. It's not going to make a difference here, but let's say minus 22x plus what number, right? What number should go here to make it a perfect square trinomial? Well, again, same formula, right? Take the b value divided by 2 and then square it. So our b value is negative 22. So negative 22 divided by 2 and square it. So that's going to be a negative 11 squared, which means it would be a positive 121. So that's the number that would go here. So that is really right there, that's completing the square. But there's a lot more math involved when it comes to writing this into vertex form or finding the zeros of it as well. So let's go to one of these. All right. So from this equation, it's showing us that this trinomial isn't quite that easy to factor. If you take a look at this trinomial, x squared plus 4x minus 8, there are no factors of negative 8 that would add up to 4. So it can't easily be factored, but we can still rewrite it into vertex form. So here's, you can click through the arrows and it's going to show you everything, but I'm going to kind of explain it in my own words, what they're doing here to write this in vertex form, okay? So they're going to get that answer of x plus 2 squared minus 12. So it's the same equation as before. It's the same as the x squared plus 4x minus 8, but it's the same equation in vertex form. And you can see that the vertex would be a negative 2, negative 12 as the vertex. But let's show you how they're going to do that. So they have x squared plus 4x minus 8. x squared plus 4x minus 8. So here's the thing. The thing that is kind of the problem with this is it's not a perfect square trinomial. So what we're going to do, because the c value is not the right c value that it should be. So what we're going to do is we're going to push this c value aside. So we're going to have x squared plus 4x plus blank and then minus 8. So we're pushing the c value aside, and our goal is to kind of create a new c value here. Make a new c value here that will make this into a perfect square trinomial. So we're kind of just done. We're not getting rid of the old c value of the minus 8, but we are kind of pushing it out to the side. We're sort of saying, we don't really like you here. Can you go stand on the other side of the room? That's what we're saying. Okay, but it's still there. It's still important. So just remember that. But now our goal is to find a new c value to fill in its place. And so we complete the square like we did just a second ago, right? Take the b value divided by 2 and square it. So our b value is clearly 4. So we're going to do 4 divided by 2, and we're going to square it. So 4 divided by 2 is 2, and 2 squared, of course, is 4. So our new c value should be 4. Okay, so remember, it's just using a really basic formula to find out what number should go as a new c value. But here's the thing. Since we're adding this number brand new to the equation, we have to also, and this is the part that everyone forgets, we have to also subtract that exact same number from the equation, because you can't just add a number in and expect the equation to be the same, right? You have to add it in, but then also subtract it out so that the equation is still the same thing. It's still balanced, right? If I were to simplify this, the plus 4 and the minus 4 would cancel each other out, and I would just be with that minus 8 again. So that still needs to be there. So it's very important that once you find that number and you replace the c value here, that it also goes over here with the negative 8. Because think of it like this, right? We took the negative 8. We kind of said we didn't like it, so we moved it to the other side of the room, right? Go away from us, negative 8. And we replaced it. We got a new friend in its place, a better friend. Good for positive 4, our new c value. But we feel bad about negative 8, right? We kind of pushed it out to the side. It's all by itself. So we found our c's twin brother, and we told this 4, its twin brother, to go hang out with negative 8 for a little bit. So negative 8's less alone, right? So negative 8, bad friend, kicked it over to the side. We've replaced it with new friend, but we took new friend's twin brother, and we said, hey, go hang out with negative 8 for a little bit, because he's lonely. But it is a minus 4, okay, because his twin was a positive 4. So they are a little different, right? So you got to keep that in mind. Whatever number we're adding here, we're actually just subtracting it from this one, okay? So here's what we do now. Now this is a perfect square trinomial, which means it factors into a perfect square. We talked about this, I think it was 8.04 or 8.0, no, 8.05 is what I think it was. This factors into x plus 2, x plus 2. Essentially, whatever that b divided by 2 value was is the number that's going to go here, okay? X plus 2 times x plus 2 is simply just x plus 2 squared. So we're going to write it like this, okay? So really, whatever b divided by 2 is going to be this number. And then we just have to simplify the part on the outside, the negative 8 and negative 4. The outsiders, we have to put them together. So negative 8 minus 4 is negative 12, so minus 12. And there you go. Now you've got your vertex form. So the vertex of that equation would be a negative 2, negative 12. Not that that's really important right now, but that's how you write the vertex form. Okay, we're going to do some more examples, okay? I think the more examples we do, the easier it becomes. So if it seems a little bit odd right now, that's understandable. But like I said, the more we do, the better it'll be. So you can see that's what they get as the answer there. So let's try our own problem. Let's try this one. X squared plus 6x minus 4. So x squared plus 6x minus 4. So the minus 4 is not what we want it to be, right? It's not going to make this trinomial perfect square. So what we're going to do is we're going to tell it to go to the side of the room. Okay, so we're going to have x squared plus 6x. We're going to find a new friend instead, okay, into our group. But the minus 4, we're pushing aside, okay? We're going to replace that minus 4. We're going to replace that c value with a new c value. And remember, this one comes in so that it makes a perfect square. So to find the c value we're going to use, we have to use that really basic formula. So the b value in this case is 6. So 6 divided by 2 squared. 6 divided by 2 would be 3, so 3 squared. 3 squared is 9. So our new number is going to be 9. So we invited 9 along, and now it makes a perfect square trinomial. But the minus 4 is alone, remember? So we're going to tell 9's twin brother to go hang out with minus 4. So twin brother minus 9 is going to come in and hang out over there. So whatever number we add here, we have to subtract with the minus 4, okay? Whatever's on the outside. And so now we just have to simply kind of write our answer. The b divided by 2 part, right, that was 3. So our factored form of all this is just going to be x plus 3 squared. And then when I combine the numbers over there, minus 4 minus 9 is going to be a negative 13, so minus 13. And there you go, you got your factored form. So this number is always going to be half of b. Whatever half of b is, it's going to be that value. Okay, it's not the number you squared it with, but it's the half value. Okay, let's do another. Again, the more practice we have, the better. Let's try, these are the same problems, just in different steps. So here's your factored form again. I'm sure we'll have some more practice. Here's another one. Okay, so we have 3x squared plus 12x plus 9. So 3x squared plus 12x plus 9. Let me think about that one. This one's odd because you have a different a value, but okay, I see what they want us to do. All right, this one, because I noticed the a value is not 1 like it typically is, right? It's 3 in this case. That's something I want to kind of notice or look for, and that's a GCF. And immediately I think, okay, the only way this is going to work is if I can factor out a GCF. And it's true, there is a GCF. Every term here I can factor a 3 out of. So that's going to make this problem easier. So let's factor the 3 out. That leaves us x squared plus 4x plus 3. So I factored the 3 out, which is good. So now I can focus on factoring this. So let's really put our attention on the x squared plus 4x plus 3 right now. Okay. Yes, the 3 is still here on the outside, so let's not forget it and put a lot of stars next to it to remind me that it's very important. But let's focus our attention on the x squared plus 4x plus 3 because we need to rearrange that into vertex form. So here's what we're going to do. Remember, the 3 is not what we want it to be. So we're going to send it aside, remember. So we're going to have x squared plus 4x. We're going to find a new c value, okay? But the plus 3, we're going to neglect. We're going to push it outside, move it to the other side of the room. So now what's the c value we need to replace it with? So how we find that, remember, is we take the b value, divide it by 2, and then square it. So the 4 is our b value, and then we divide it by 2. So 4 divided by 2 would be 2. And then we square it. 2 squared makes 4. So the new c value is going to be 4. So we're going to take 4's twin brother, remember? We're going to subtract that 4 with the 3 that's all by itself, all alone. So we have our equation we just need to simplify. So remember, half of the b value, b divided by 2, half of 4 is 2, which means this will just be x plus 2 squared. And on the outside, the plus 3 and the minus 4 is going to be negative 1, so be minus 1. So there's our factored form. Now the trick is, remember that this is all multiplied by that 3. The 3 is on the outside. So I'm curious how they're going to write this. I think they'll probably write this as 3x plus 2 squared minus 3. Because that 3 is going to get distributed. And it's going to be multiplied with the x plus 2 squared, and it's going to be multiplied with the minus 1. So I would think that it would look like this. So let's see how they've written all the way in step 5. Yep. They did it slightly differently than I did it, but they still got the same result. So that's very interesting. But either way, we came up with the same answer. But yeah, they walk you through the steps a little differently than I've worked it out. So let's see, like I said, if there's any more examples, because the more we can do, the better. All right. let's do this one right here. The negative 2x squared plus 6x minus 7. No. Hold on, let's not do that one. I mean, I guess you could, but it's gonna be different than what I just did. Let's try it. Let's see if we can do that one. Okay, the negative 2x squared plus 6x minus 7. So negative 2x squared plus 6x minus 7. Make sure it's right. Okay, so in this case, what they're actually going to do is there is no GCF for all the terms, but the a value is not 1. So when the a value is not 1 and we can't do a GCF out of the whole group, then what we're going to do is we're going to try and take a GCF just out of the first two terms. Is that going to work? I think that might work. So we're going to take out a negative 2x. No, just a negative 2 out of this, not even the x. Just take the negative 2 out and leave it as x squared minus 3. Minus 3x, sorry. All right, and then the minus 7 is still chilling on the outside. So we're factoring out this negative 2 just so that we can have like a plain x squared here. All right, so now what we're going to do is we're going to try and fill in a c value for this parentheses part. So negative 2 x squared minus 3x. We're going to try and find a new c value that's going to join, that set of parentheses. So the c value that we're going to find, let's see, we're going to take our b value of negative 3. We're going to divide it by 2. Remember, b divided by 2 squared. So that's going to be negative 1.5. And then square negative 1.5. What do we get? We get 2.25. So 2.25. And so we're going to take 2.25's twin brother, subtract it from over here. Actually, sorry about that. We're not actually going to take the 2.25. We have to double the 2.25 because negative 2 times that 2.25 is going to need that. So we're actually going to add, because it's all right, so negative 2 times 2.25 is, oops, typed it in wrong, is negative 4.5, which means we would have to add a 4.5 to this side. So negative 2 times this number, like I said, because that negative 2 is still there, it's kind of relevant. This is a very odd problem, I'll give you that much. It's negative 4.5, so we're going to have to add the 4.5 to the negative 7 so that everything is balanced still. So when we write this final version out, we'd have, because the half of negative 3 is negative 1.5, we would have x minus 1.5 squared. And then over here, we would simplify that to negative 7 plus 4.5, which would be 2.5, negative 2.5, so minus 2.5. I believe that is the correct answer, but we will check it and see how we do. Yes, they kept it as fractions, the 1.5 and the 2.5 as 3 halves and 5 halves, but that is still the right thing. That is a very tricky problem, so if that one went over your head, don't worry about it for now. You can always come back and rewatch that or review it in the future. Let's go back to a more basic one, though. So I apologize if that one kind of goes over your head a little bit. Let me see if I can find an easier problem to show you some more of. So we'll come back to those because it's a little different, but let me see if I can make one up real quick. So let's say you have x squared plus 6x minus 10, right? And we want to put this in vertex form. Well, the minus 10 is not good. So remember, we're going to split it off to the side. So we'll have x squared plus 6x plus new c value, right? But off on the side, we've pushed the 10 away. The minus 10, we've pushed it away. So to find the correct c value, we take half of b and square it. So b divided by 2 squared, remember, same formula. So 6 divided by 2 is going to be 3. So we're going to square that. 3 squared is going to be 9. So we have a plus 9 here, which means plus 9's twin brother, negative 9, is going to join the negative 10. And so when I put this final answer in its final form, we're going to have x plus half of b, which was 3 again, so half of b, which was 3. We're going to have x plus 3 squared. And then over here, we're going to have the minus 10 minus 9 be negative 19. And that's your factored form. Okay? Again, I think the more of these you can do, the better. Let's see if I can even make up another one. Right? So let's say I've got this, right? So again, we're going to take the c value that's here. We're going to set it off to the side. So we're going to have x squared plus 12x. We're going to find a new c value. And we're pushing the 20 off to the side. So how do we get the c value again? Well, remember, we take half of 12 and we square it. Half of 12 is going to be 6. So 6 squared is going to make 36. So that's our new c value, which means we're going to have to take its twin brother, negative 36, and join it with the 20. So now when you write your final form, remember, half of 12 is 6. So we're going to have x plus 6 be our squared part, x plus 6 squared. And then on the outside, 20 minus 36 is going to become negative 16. So we combine all that to be negative 16. There's your final answer. So it's not a very long process, but it can be kind of tricky, especially at first, and especially when you get to those harder problems that we struggled with, before this. Okay, but now how do you solve quadratics? Remember, we solved them through factoring before. How can we solve them using this method? So let's solve x squared plus 6x minus 9 equals 7. X squared plus 6x minus 9 equals 7. Did I write? Let me just double check I wrote that down right. Yes. Okay, so when you're solving quadratics, the number one thing, to solve, here's the key word, to solve quadratics, you have to have everything equal to 0. So this is equal to 7, not what we want. So what we're going to do is we're going to subtract the 7 on both sides to move it around and have 0 on that side, on the right. So we simplify this to x squared plus 6x, and then the minus 9 minus 7 will combine to be negative 16. All right, so that's the number one step, is you have to have it set up properly. So the setup means that you have your quadratic where everything is on one side and then it's equal to 0 on the other. So now we just have to use the completing the square on this. So we're going to have x squared plus 6x plus the new c value, because what we're going to do is we're going to take the old c value and push it to the side. So the minus 16 we're going to push to the side. Right? So we have to find, of course, it's still going to be equal 0 this whole way down. So still equals 0. Find the new c value. So we're going to take the 6 divided by 2 and then square it. 6 divided by 2 is going to be 3. So 3 squared is going to be 9. So we're going to have 9, which means we have to join that 9's twin brother, negative 9, with the 16. So when I complete factoring, half of 6, remember, was 3. So it's going to be x plus 3 squared. And then the minus 16 minus 9, that combines to make a minus 25. And again, equals 0, still equals 0. All right, so now we've gotten this far. We just have to solve it using regular math skills. So from here, what we're going to do, it seems kind of opposite from what we were just talking about, being equal to 0. But now look, we finished the vertex form, right? We are now in vertex form. So once you've reached this stage in the problem, we are just going to solve for x. So to solve for x means we need to get x by itself. We need to isolate x. So we're going to add the 25 to the other side, because that's one less thing that's on the same side as x. So it would be x plus 3 squared. It's the only thing that's going to be on the left. And then 0 plus 25 would be 25. Okay. So now, because x plus 3 is inside the parentheses that's being squared, we have to get rid of the squared. So the opposite of squaring something is to square root something. So we're going to square root both sides. And what happens is when I square root the left side, it just cancels out the squared. So the x plus 3 remains unchanged, but now it doesn't have the squared. It won't be squared anymore. It'll just be x plus 3. But remember, you're square rooting the other side. Now, here's the really fun part. If I didn't make this confusing enough, the square root of 25 is two numbers. The square root of 25 is both a positive 5 and a negative 5. So that means that we actually have two equations here. We actually have x plus 3 equal to a positive 5, but we also have x plus 3 equal to a negative 5. So to make this even more confusing, we've now made two equations. But after that, it's really easy to solve for these two answers. You just subtract the 3. Let's solve one at a time. Subtract the 3 here. We'll have x equal to 5 minus 3, which is 2. And on the other side, when we subtract the 3 to cancel it out, we're going to have x equal to negative 8. So we have these two values as our answer from 2 and negative 8. Because remember, quadratics have two roots, two x-intercepts most of the time. Not every time. Sometimes they have 1, sometimes they have 0, but most of the time they have 2. So you should be expecting two answers. And the only way you get two answers is from two equations. And those two equations come from after you square root a number like that. Because the reason why it's positive and negative is because positive 5 squared is still equal to 25, but negative 5 squared is also equal to 25. So there's two numbers that when you square can make 25. So that's why we have those two possibilities listed out to make our two equations. But yeah, you solved it. X equals 2 and x equals negative 8. There's plenty more where that came from, so let's try another. Let's do, I guess we can try the example they have here. Although that's going to be a little bit more difficult, but we can still do it. Negative 2x squared plus 8x plus 2 equals 4. So negative 2x squared plus 8x plus 2 equals 4. So again, the number one thing is it has to be set up equal to 0. So we're going to have to move this 4 over for now so that this whole thing can be equal to 0. And so that means we'll have negative 2x squared plus 8x, and then 2 minus 4 becomes negative 2. Now, the number one thing I notice is that before I do completing the square, I notice that everything here has a GCF. All these terms can be divided by 2. In fact, they can divide by a negative 2. So I'm going to factor out a negative 2 first. So negative 2 can come out, which will leave you x squared. Then this becomes a negative 4x. And at the end becomes a positive 1. All right. So we have the negative 2 chilling here. So don't forget about that. It's very important. But let's focus our attention now on completing our square. So we have... let's focus on the x squared minus 4x plus 1 for now. We have to move this 1 out of the way. So we're going to have x squared minus 4x plus a new number, and then plus 1 out of the way. So in order to find the new value, remember it's just b divided by 2 squared. So b, of course, is negative 4. So negative 4 divided by 2 squared, that's going to be negative 2 squared, which is still just 4. So that means we're going to have to subtract the 4 here. As its twin brother, join the 1. So this becomes x, since half of negative 4, remember b divided by 2, half of negative 4 is negative 2, this would be x minus 2 squared. And then this combines, plus 1 minus 4, combines to be negative 3. So that's it factored, but don't forget that this still had the negative 2 on the outside. So when you bring that negative 2 back into play, you're going to have the negative 2 join the x minus 2 squared, but also it's going to be multiplied with the negative 3 to become a plus 6 here. So it's kind of like distributing, but you're not distributing into those parentheses. You're just applying it to that group, but you are multiplying it with the minus 3. And lo and behold, this is still, guess what, all equal to 0 right now. But now you have something that's in vertex form. So we've made it all the way to vertex form. So now we just have to solve it for x. So lots of steps here. First thing we're going to do is get rid of the plus 6. Opposite of plus 6 is subtract 6. So So we're going to get rid of that. So it's going to be negative 2, then x minus 2 squared equal to negative 6. Then we're going to get rid of the negative 2 that's on the outside. So since negative 2 is multiplied with x minus 2 squared, we're actually going to divide by negative 2 in order to cancel it out. So we're going to divide both sides by negative 2. That's going to now leave us with x minus 2 squared equal to a positive 3. Okay, I want to make sure everything's right here. Everything seems good. Let me just check my progress real quick. I want to make sure I haven't messed anything up. Okay, yeah, they do have the square root of 3. Okay, so we're still good. I was a little bit surprised because of the next step here. So first, keep in mind, we've gotten rid of the 6. Now, last step, we got rid of the minus 2, or the negative 2 on the outside. So now we're going to get rid of the square. The opposite of squaring something is to square root something. So we're going to square root both sides. So that's going to cancel out the square and just leave us x minus 2. But the square root of 3 isn't the perfect square, which is why I was a little confused for a minute. I wanted to make sure I was doing it right. Square root of 3 would just be a regular decimal because there is no number that times itself equals 3. So what we're going to do is we're going to leave this as a square root of 3. However, just like the 5 before, when you square root something, you're going to have a positive and negative version of it. So we're going to have a positive square root of 3 and a negative square root of 3. So this always comes after the square root part. After the square root part, okay, square root is how I simplify that. You're going to have the positive negative come after it. So positive square root of 3 and the negative square root of 3. So we're going to have two equations from it. X minus 2 will equal the positive square root of 3, and one of them, x minus 2, that equals a negative square root of 3. And when we solve it, we'll just add 2 real quick to this side. And that 2 does not combine with the square root. It's just simply going to be x equals the square root of 3 plus the 2. When I add 2 to the other one, it's going to do the same thing. So you're going to have x equal to the negative square root of 3 and then plus the 2. So you have these two answers, a positive square root of 3 plus 2 and then a negative square root of 3 plus 2. Sometimes people like to write this instead as 2 plus the square root of 3, and this one as 2 minus the square root of 3, because those are still the same thing as before. And some people like to even go a step further and combine both of these into being the same thing as 2 plus minus square root of 3. So sometimes they write both answers kind of at the same time by putting a plus and a minus square root of 3. But yes, this here is still the answer. I'm just showing you this is one other way to write it, and then this is one way to write it all together. So you might see that. Just want to point it out. But yeah, they didn't write it like that here. But this can be really confusing to read at first. So that's why I kind of want to at least put in the video. Okay, so this is just a word problem version of it now, but it's still kind of the same thing, right? In order to maximize profit is going to be the top of your parabola, right? The peak of your vertex. So when you're reading a question that says maximize their profit, the word that needs to come to your mind is maximize means top means vertex. So you need to find the vertex of this equation. Negative x squared. What is the equation? Plus 30x minus 125. Plus 30x minus 125. So to maximize profit means it's asking you to find the vertex. So of course you can do this two ways. You can either do what we did in the previous chapter, which is, find the axis of symmetry and then plug that value in, find the vertex, or you can just rearrange it in the vertex form. So we're going to, of course, rearrange it in the vertex form here as practice. So to do that, I think the main thing, I do want to get rid of that negative. Let me see how they do it, just out of curiosity. Okay. Let's do it the way they've done it. Okay, so what they're going to do is they're going to take the negative out of this first two terms. So they're going to take the negative 1 out of those two terms. The negative 1's going to come out, making a positive x squared and then a negative 30x. But they're going to leave the minus 125 alone for now. So what they want to do is find the proper c value for this quadratic here. So x squared minus 30x plus some c value. We want to find out what c value we want to put in there. So of course we have to complete the square. So we take half of negative 30, so negative 30 divided by 2, and then we square it. So that's going to be negative 15 squared, and negative 15 squared is 225. So the number that we're going to put here is 225. So when I factor that, the half of 30, remember, was negative 15. So we're going to have x minus 15 squared part here. But before I do that, remember, I have to put the 225 over here as well. Now, before I do that, because I had to pull up this negative 1 times 225 would mean that this is negative 225. So if that's a negative 225, then the one part I have to put over here is a positive 225, its twin brother. Yes, I know how confusing that can be, but this is only that confusing because we had to take out a number like this before. Whenever you take out a number, it has to be reapplied. So the negative 1 has to be reapplied to this number so that you know what that number really is. So the negative 1 times 225 means that that number is really a negative 225, which is the reason why I'm putting its twin brother, positive 225, over there. Okay? So that means negative 125 plus 225 is going to be 100. So it would be plus 100. Remember, all that is still equal to 0. Or no, we're not equaling to 0 yet because that is vertex form. So our vertex means at 15 is our h value or x value, and 100 being the k or y value. So our vertex is 15, 100, or essentially 15 cups of coffee, and I guess the profit is $100. And that's what they have there. So now it's asking how many cups will they need to sell to break even. Break even means that they don't make any money, right? So breaking even means 0 profit. So we're essentially looking for when all of this, which is what I was jumping into earlier, all this equals 0 profit. Well, if they have 0 profit, we're just going to solve this from scratch. It's already in vertex form, so we just have to solve it the old-fashioned way. So we'll subtract 100 first to cancel it out. Have negative 1, x minus 15 squared equal to negative 100. We're going to get rid of the negative 1 since it's being multiplied to x minus 15 squared. We're going to divide by negative 1 to cancel it out. So that's going to leave us with just the x minus 15 squared equal to a positive 100. So now we have to do the opposite of a squared. So the opposite of squaring something is square rooting something. Now remember, after you square root, guess what happens? Positive, negative. That's a very important thing to remember. So I'm going to cancel out the square, which means I'll just have x minus 15 now. And the square root of 100 is 10. But remember, it's positive and negative. We're going to have a positive 10 and a negative 10 here. So that's when we split into two equations. X minus 15 equal to a positive 10, and x minus 15 equal to a negative 10. So we solve these two results. So we'll add 15, solve for this x is going to be 25, and then add 15, solve for this x. This x would be a positive 5. So 5 and 25. They make no money if they sell 5 cups of coffee and they sell 25 cups of coffee. There's your work all done. And the last step is, when would they start losing money? Well, if they start to break even at 25 cups of coffee, that means after they sell 25 cups of coffee, they're going to go lower losing money, right? So 25 is the mark where they stop making money, right? At 25 cups of coffee, they went from making money to not making no more money. So if they sell any more cups of coffee, then they're going to continue losing money. So it's after the 25 cups of coffee that they start losing money. That's pretty much everything I can really tell you about vertex form. Yes, it's definitely going to be pretty tricky, especially those ones where it's not a regular x squared. If it starts like 2x squared or negative x squared, those are going to be really, really tricky. So rewatch those examples over and over and over again to kind of get the idea, because every problem does work out the same way, just different numbers. So be very careful how you do that. And good luck to you guys. Remember, we're always here to help, answer your questions in the discussions tab, or just ask us whatever you need. Okay, we're happy to help you guys. So good luck on this. I'll see you guys next week.